In this lesson, we're looking at direct and inverse variation. Starting with direct variation, if we look at this equation here, y equals k times x, as you can see, as x value increases, y value will also increase. So imagine if x was 1 compared to when x was 3, you can see when x is 3, we'll end up with a bigger y value because k is also just a number. So an example would be y equals 2x, and as you can see, if we put 2 as x, that y will be 4. If we put 3 as x, y will be 6. So as you can see, as x values go up, y values also go up. So we call this direct variation, and it always follows this equation of y equals k times x. Now, if we were given the x value as well as the y value, then you can find the k value even if it's not given to you. If we do a little bit of algebra here, to find k, we'll have to divide both sides by x. So k will equal to y over x. So if we have the y value and the x value, and we do y over x, we can find the k value as well. And if we have a direct variation and we graph it, it will always go through the origin where the values are 0, 0 for x and y. So let's look at this example together. In this example, we're looking at distance and time, and it's saying that it goes up at a constant speed of 100 kilometers per hour. If something goes up at a constant rate, this means the k value is there and it's not changing. So we just have the relationship of y equals k times x. But in this case, instead of x and y, we have distance times k times t for time. As you can see, we're using d and t for our values. And we're asked to find the equation for this question. So to do that, we can just pick, we're given so many points here, we can just pick one of them. So let's pick the easiest one with the lowest values. So if we're substituting 1 hour and 100 kilometers for distance, then we end up with 100 equals k times t, and t in this case is 1, so k has to equal 100. So in this case, our equation is y equals 100 for k times x. And because we're given this in terms of different variables than x and y, we should write it as distance equals 100 times, and instead of x, we should write time. Do this next example together as well. If we see this sign with x and y like that, this means that they're directly proportional, meaning they're following this equation. So using this idea, we can find the constant of variation, the k value, from this table by picking one of the points. So k is always going to be y over x, so 10 over 2. So it's going to be equal to 5. If we know k is 5, we know that the equation is y equals 5x. So using this equation, we can complete this table. So when x is 4, so imagine a 4 there, then y is 5 times 4, which is 20. And for this last bit, we need to work backwards. When y is 100, x has to be 20, because 20 times 5 is 100. So I've done this question here already. And this next example here is asking if x and y are directly proportional. To do that, we just need to see if these are going up at the same rate, because if they were directly proportional, they'll follow this equation and this will have to be the same. So for the first bit, we can see it's going up by times 3. Same for the last bit. However, here it's not quite going up by times 3. So they're not directly proportional, because 12 divided by 4, which is 3, is not the same as 20 divided by 7, which I got from here. So if they were directly proportional, it will be 21 instead of 20. So not directly proportional. The next bit we're looking at is inverse variation. So unlike the direct variation before, this time y will be inversely varying the x, meaning that it's going to follow this. So instead of y equals k times x, this time we have y equals k times 1 over x, and we call that inverse variation. Another way of writing this would be k over x. That would mean the same thing. Now, because our equation is a little bit different, to find our k value, we are just doing a little bit of algebra. So timesing x on both sides to make k on its own. So k is y times x. So if something is inversely proportional, to find the k value, you can do x times y. And you know that it follows this equation. Now let's look at these examples here. This example is telling us that they're inversely proportional, x and y, and asked to calculate k and then find the equation of x and y. So we know to find k, it's going to be x times y. So we just pick a pair. So when x is 1, y is 3, so k has to be 3. We also know that it's going to follow this formula, k over x. So then our equation is going to be 3 over x. This next bit as well, to find k, let's pick a pair of coordinates. So when x is 2, y is 1, so k is 2. So then we know y equals 2 over x is the equation. Now these two are worded examples. Best way to do worded examples is sort of annotate what you know as you read the question. So we're dealing with the height being inversely proportional to the squared of the radius. So height, let's make it h. Radius is r. Let's use a different color. But then it's square of the radius, so it's going to be r squared. And inversely proportional, meaning that it's going to be y equals k over x as our equation. And then the next bit gives us some values. When height is 15, the radius is 4.2. So let's put all of these together. So instead of y and x, let's have h equaling k over r squared. And then we know when h is 15, let's use this k being x times y. So 15 times 4.2 squared in this case, because we're squaring the radius, is going to be k. So k has to be 264.6 then we know the equation is h equals 264.6 over r squared. And then the question actually asks us to find the height when the radius is 3.5. So to do that, we need to substitute the radius into the equation that we have over 3.5 squared. And you just put that in the calculator. It's 21.6 centimeters as the height. Alright, this last example is quite similar. We have time, and it's inversely proportional to the rate of pumping. So time, let's make it t, inversely proportional, so following this equation, rate r, and then the next bit tells us it takes 2 hours, so t is 2, when the rate is 1200. So using that, we can find the k value, so 2 times, this is the k value, which is 2400. Then we know the equation is, what is it? Instead of y, we have t. Instead of k, we have this, and then over r. And then the last bit is asking us to find t, how long it will take if the rate is 2000. So t equals this over 2000, which is 1.2 hours.